Today we're going to talk about piecewise functions, and for piecewise functions we're going to do three different things. We're going to learn how to evaluate them using both a graph and an equation. We're going to write equations, and we are going to graph piecewise from equations. So real quick start, you see a piecewise function here. All piecewise functions that we're going to work with are based off of your parent functions, which is another reason that it's really important to know those. You see here, you should recognize in this piecewise function two quadratics and one linear function, which is what you see on the graph next to it. There's a quadratic that corresponds to that first one. There is a linear function that corresponds to the second equation, and there is a second quadratic that corresponds to the third one. So you can evaluate a piecewise function off a graph just like you would any other graph. If I ask f of negative 2, just note that your graph is counting by 2s, so f of negative 2 is going to be right there. That has a y value of 2. F of 0 is going to be right here in the middle, therefore that's going to be 0. F of 2 will be at the second connecting dot, which is at negative 2. F of 4 is at the top of this hill, so 2. And f of 6 is down here, which is negative 2. You should also be able to do the exact same thing from the equation. And now you can see this on your paper. I'm going to keep my graph and my page here so that you can kind of see what's going on. To evaluate f of negative 2, I have to check out these restrictions right here. And I have to make sure that I pick the section that my x value fits into so that I get the correct answer. So my first question to myself then on this one is, what does negative 2 fit into? Well, because this symbol tells me x is less than or equal to negative 2, I'm going to use that first equation to plug in negative 2. When I plug in negative 2 right there, I have 2 squared minus 2 gives me 2, which is the exact same answer I got here. Same type of thing for f of 0. For f of 0, I'm going to go ahead and check where does that fall. Well, 0 falls between negative 2 and 2. Therefore, I'm going to plug it into this first equation. Can't really have a negative 0, therefore my answer is 0, just like I got here. F of 2, same thing. 2 does fall within this second restriction because it's equal to 2 there. So I'm going to plug it into that second equation, giving me negative 2, just like I got from the graph. F of 4 and f of 6, both 4 and 6 are going to fall into this category of x being greater than 2. So I'm going to plug them into the third equation. So negative 4 minus 4 gives me 0 plus 2 gives me 2, just like I got here. And negative 6 minus 4 squared plus 2, 2 squared is 4, negative 4 plus 2 is negative 2, just like I got from the graph. So real quick, we're going to go ahead and practice that on the graph below. And this one has your graph given, your equation off to the side. Take a minute on your own paper and evaluate both from the graph and confirm using the equation that you're given there. When you are done, go ahead and check your answers against mine. You see I had the dots drawn on the graph there to show you which points we're looking at. And then that negative 4 falls into the restrictions of x being less than 1. So I plugged that into the first equation from the piecewise function. And to find f of 1 and f of 3, both of those fall into the x is greater than or equal to 1 category. So I'm going to go ahead and plug them into that second equation. All right. Now the second thing we're going to do is go ahead and look at how to write equations from a graph of a piecewise function. When I look at this graph right here, I should see that there are 4 separate sections. And if you're a highlighter or you're a colored pen person, you can go ahead and highlight sections here. So you should be able to recognize a couple things. First is that I see on the left-hand side this being a linear function. This is like a y equals mx plus b. We're going to write that equation. This second section is just a horizontal line. That one will be very easy to write. The third section is another y equals mx plus b line. And the fourth section looks to me to be more of a curve. So I'm going to go with a quadratic on that one. So we're going to see what that is going to look like here. This is a quadratic looking. All right, so to write this y equals mx plus b one, the first one, and this is a quadratic like I said, we like to write those in vertex form. And we're going to show how to put this all together. The first section, the green one, we're going to go ahead and find what we know about it. To write the equation of a line, we need slope and y-intercept, or point slope form. So in this case, again, notice your graph is counting by twos. So if I look at this, I'm going to go ahead and look at 2 points on here, and I'm going to count up and over. It's going up 4 over 2, so my slope is 2. And then I can use point slope form with either one of those points and do y minus, let's say I use this top point, y minus 4 is equal to 2 times x minus 2. Distributing and solving in this case gives me y equals, this is going to give me 2x minus 4, or excuse me, this is a negative 4 here, so that's going to be a plus 4. So when I subtract from both sides, I'm going to get y equals 2x. This is not correct. What did I switch my signs on? This is the point, negative 4 up to, I switched my x and my y. There we go. Let's go back here a minute. So if I do, using my point, negative 4 up to, it should be y minus 2 is equal to 2 times x plus 4. There we go. Distributing and solving gives me y equals 2x plus 8, and when I add to the other side gives me 2x plus 10 for that green section. The orange section, like I said, should be very easy to write. It's a horizontal line at 2, so it's y equals 2. The pink section, I got to look at a little bit carefully here. This one, the points that I have here are 1, 2, and 1, 2, 3, 0. So to get this one, I notice that the slope is going to be down 2 over 2, or negative 1. And I would go ahead and do y minus 0 equals negative 1 x minus 3. So that equation is going to be y equals negative x plus 3. The quadratic that I have here, we're going to use that 3, 0 as the vertex. And notice that it goes over 1, down 1 to get to this next point right here, which means the slope is negative 1. So that blue section, the quadratic, is going to be y equals negative x minus, the x point of the vertex is 3 squared, and I don't have to write the plus 0. Now let's put that all together in a piecewise function over here. First off, we do f of x is equal to, we do our bracket, and we put our 4 equations inside without their y equals. So I have 2x plus 10, I have 2, I have negative x plus 3, and I have, as my fourth one, negative x minus 3 squared. We also have to put restrictions on these, and this is rather like doing the domain. The green section, if I look at it, starts at negative infinity and goes all the way up to an x value of negative 4. So I'm going to use x is less than or equal to negative 4. The horizontal line goes between negative 4 and positive 1. Now I've already used negative 4 in the green one, and you can kind of choose which one it goes with. In this case, I've already used it in the green section, so I'm not going to put that it's equal to negative 4 because you can't use it twice. And I'm going to go ahead and say that this one goes over to a an x value of 1, and I'll include 1 there, but I won't include it in the next section. So then that pink section goes between x equals 1 and x equals 3. We've already used 1 in the previous section, so we're going to say between 1, and then I'll go ahead and let's just not include 3 in this one. We'll just say it's not included with that, and we'll include it in the quadratic. So the quadratic then starts at 3. X is starting at exactly 3 and going all the way out to infinity on that one. So that is how we write equations from graphs let's quickly take a look at graphing these. We're going to skip to the next page. So graphing these piecewise functions works almost exactly the same way, only you just have to know the parent functions and how to graph them from here. So from here, this first one is y equals -2. So if I was to graph the entire thing, that would be a horizontal line at -2. But I have restrictions on this. This one says x is less than -1. Less than simply means an open dot at -1, and it means keep the section to the left. So I'm going to go ahead and erase the section to the right and just keep the section to the left. That second one is a quadratic. That quadratic has a vertex of 1, -6, and a slope of 1. So that quadratic would look something like this. This one wants us to keep the section between 1 and 3. Now, we don't have a point for 3, so I'm real quick going to plug in 3 to that equation and see what it is. 3 minus 1 is 2, squared is 4, minus 6 is -2. So that means I have a point right there. And it wants me to keep the section between -1 and 3, which means I'm going to fill in that was an open dot before and keep that section of my quadratic. The third section is a square root function, translated right 3 and down 2. So right 3 down 2 starts my square root function just where that other one stopped. Technically it's an open dot, but since there's already a closed dot, that takes care of it. And it says to keep the section that is greater than 3, which is the entire thing since square root functions go out to the right. You could then, state the domain of this. The domain of this function would be from -infinity all the way out to infinity because there's no breaks. In this case, the range, the lowest y value for this one would be -6, and it would continue all the way out up to infinity. For another example of that, let's take a look at the next one. Again, using parent functions. The first one is the line 2x minus 8. So just like normal lines, we start by graphing at -8 and doing a slope of up 2 over 1, up 2 over 1, so on, down to left 1. This one wants us to keep the section for x is less than 2. So at 2, I'm going to erase that closed dot and draw an open dot and keep only the section that is less than that or to the left. This second one is an absolute value function that is translated right 3 and up 1 and is negative, therefore goes like this. This one wants me to keep the section between 2 and 4 only, but including the closed dots. So that means I'm going to erase right up to that and right up to that, giving me just that small little V section there. And last but not least, this one is a cubic function, which is moved right 4, up 3. So my cubic function is this S shape that looks like this. Gotta be careful when I erase this. This one would like me to keep the section that is greater than 4. So I'm going to go ahead, carefully erase this section over here. And make sure that section starts with an open dot. If I was to do the domain on this, the domain on this is perfectly fine. If you follow the section from left to right, it would start at -infinity. This open dot is taken care of by that closed dot, and this open dot is taken care of by that closed dot, so it goes all the way out to infinity. For my range on this one, I would start at -infinity, go all the way to this open dot at -4. I would pick back up at 0 and go to 1 with closed dots or brackets. 0 to 1. And then my third section for my range would start at 3 and go out to infinity.